Hey coders, welcome back to Code Tech Chronicles. I am Shashi Devendra and today we are continuing our data structure series with one of the most fundamental and widely used linear structures in computer science, stack and queues. Whether you are preparing for coding interviews or building real-world software, understanding these two structures is essential. In this video, we will break down how they work, when to use them, how to implement them, and even solve some common practice problems. Introduction. Stack and queues are both linear data structures. That means elements are arranged in sequence, one after another. But the way we insert and remove items differ between them. Stack follows a last in first out LIFO approach, whereas queues follows first in first out FIFO. Think of stacks like a pile of books, where you take the top one off first, and queues like a line at the ticket counter, where the first person in the line is served first. These structures are used in wide variety of applications: undo mechanism, CPU scheduling, memory management, and more. So what is stack? LIFO. Stacks are all about control. You only access or modify the top element. The key operations include push, add an item on top of the stack, pop, remove the top item, peek or top, view the top item without removing it, is empty. Check if the stack is empty. Stacks are implemented using arrays or linked lists and are simple yet powerful tools in algorithm and system level programming. Some use cases of stack. Stacks appear in real life more than we realize. In computer science, they play crucial roles such as function call stack. When a function calls another, the return address is stored in the stack. Undo redo editors. Every action is pushed onto a stack so you can backtrack easily. Backtracking algorithm. Think puzzles and games that requires revisiting previous states. Expression evaluation for converting and computing infix, postfix, and prefix expressions. Parsing. Language interpreters use stacks to check nested structures. These use cases make stacks indispensable. This is an example of stack. You can see the items are inserted from bottom to top. What is queue? Queue is a FIFO structure. Queues operate in opposite manner. They are fair and follow the first come first served policy. Some key operations are enqueue, add an element at the rear, dequeue, remove the front element, front and rear, view the respective ends of the queue, is empty or is full, is useful in fixed size queues. Common applications include job scheduling in operating systems, task queues in backend servers, printers, and data buffers where order matters. This is an example of queue. You can see there is operations enqueue at the end and dequeue at the front. Circular queues is in a basic array based queue, space isn't reused after dequeuing. Circular queues fix this by wrapping around. It uses modular arithmetic to let the rear pointer return to the front, and when it reaches the array's end, this makes it great for fixed memory conditions like CPU round robin scheduling, streaming data buffers. It improves space efficiency and prevents unnecessary memory wastage. Implementing stacks and queues. Both structures can be implemented in multiple ways. For stacks, we can use arrays, simple and fixed size, use linked list, dynamic no size limits. For queues, array based needs careful handling for front and rear. Linked list based, easier insert at rear, delete at front. Choose arrays when performance and memory limits are known. Choose linked list when you need flexibility. Okay, practice problem. Balance parenthesis. This is a classic interview problem given a string containing brackets like parenthesis, curly braces, square brackets. Determine if input is balanced. Approach. Push the opening bracket onto a stack. When the closing bracket is found, pop. and check if it matches the last opening one. If the stack is empty at the end, it is balanced. Great for understanding stack behavior, especially in compiler design and expression validation. Practice problem. Next greater element. Given an array, for each element, find the next greater one to its right. Naive approach is O n square. Efficient way, use a monotonic stack. Traverse array from right to left. Use stack to keep track of elements in decreasing order. Pop until you find a greater element. Real life analogy, stock span problem, temperature rise forecast, etc. Stack versus queue. Quick comparison. Let's wrap this with a side by side comparison. Feature. For insertion, stack uses push on top and queue uses NQ at the rear. Removal. For removal, stack uses pop at top, queue uses DQ at front. Use cases of stacks are undo, parsing, recursion, while for queue it's scheduling and buffering. Access order for stack is last in first out and queue is first in last out. Both are powerful and foundational for solving real world coding problems. To sum it all up, stacks help when you want to go backward. Undo, backtracking. Queues help when order matters. Job queues, streaming. Implement them using arrays or linked lists. Practice with real world problems to reinforce the concepts. Don't just memorize, implement, visualize, and build confidence. Thanks for watching this deep dive on stacks and queues with Code Tech Chronicles. If you learned something new, drop a like, share with a fellow coder, and hit that subscribe button. Keep building, keep coding, and remember, small steps, big impact. See you in the next one.